we're on, things like that. So let's do that first. We're going to say score. Well, actually, I guess it's not score. We're just going to have level and lives. So we'll say level starts on level 1. And we'll say lives starts on 5. Feel free to increment that if you want. Doesn't really matter to me. And I'll show you how we can draw those to the window. So how can we actually draw text? So you saw I had lives and I had level at the top right and left hand corner of the screen. How do we do that? Well, the first thing we need to do is actually create a font in Pygame. So a font allows us to kind of render that font. So for example, Comic Sans is what I'm going to use. We need to create the font object and then use that font object to actually render the text to the screen. So the annoying thing in Pygame is that you need to initialize fonts for them to work. So that's pretty easy, but at the top of our program, right after we import Pygame here, we're going to say pygame.font.init. This just tells Pygame, okay, get set up, get the font ready to go so that there's no issues when we want to start using it. So that's what we'll do, pygame.font.init. And now inside of our main here, I'm going to define main underscore font, so that's a variable name, is equal to, in this game, pygame.font.sys font. And here we're going to name the font. So there's all kinds. I'm not going to go through them, but the one that I usually use is Comic Sans. And then the size of this font. So the size that I'm going to use is 50. Make it smaller or bigger depending on what you want. And now I'm going to show you how we can use this to actually draw the lives and the level on the screen. So here I'm going to make a comment. I'm going to say draw, text like that. And the first thing we need to do is make a label and then blit that label to the screen. So you saw how I blit this surface, which is the background to the screen. What I need to do is turn some text into a surface and then put it on the screen. So I'm going to say, I guess this would be lives underscore label is equal to main underscore font, which we've defined up here, which is Comic Sans size 50. Dot render, and here I'm going to type what I want to render. So in this case, I want to render an f string. If you're not familiar with f strings, what this allows you to do is embed variables inside of brackets like this. So left brace, right brace, like the curly brackets. So I can do something like level colon level. And what this will do is take the value of the variable level here and just show that. And so that's with an F preceding this string. Now that only works in Python 3.6 and above. So just keep that in mind when you're running through this. Okay, so then our next arguments are 1 and color. So 1 stands for anti-alias. You can see that's popping up here. I'm not going to explain really what that is. You're just pretty much always going to use 1 if you're blitting something or rendering text, sorry. And then color is an RGB color. So RGB stands for red, green, blue. It's a value between 0 and 255 inclusively. That means you can use 0 and you can use the value 255. And if you wanted to make, say, red, well, it's red, green, blue. So you say, I'm going to use the maximum amount of red, the minimum amount of green, and the minimum amount of blue. That would give you red. If you wanted RGB, if you wanted blue, then you would do 0, 0, 255. If you want white, funny enough, it's 255, 255, 255, because white is actually a combination of all colors. So that's why, or combination all of red, green, blue. So that's what you do like that. If you wanted black, it would be 0, 0, 0. And, you can look up RGB color codes and find them quite easily on the internet. So lives label will be that. We'll say level. Oh, I just realized I called this level. It should be lives. My bad. So lives. Let's do level label. So level label equals main underscore font dot render. We'll do an F string again, not a D string, an F string. And we will do level colon, and this time we'll do level, and then we'll do 1, 255, 255, 255. So to summarize, this has created text, which is white, anti-aliasing of 1 that has these contents, and now we need to put it on the screen. So to put on the screen, we're going to say win.blit. First one, what do we want? want the lives label, okay, lives underscore label, and the position that we want to put it on. We need to pick an XY. I want it in the top left hand corner of my screen, but not like directly in the top left hand corner, just a little bit offset. So I'm going to say 10 10. So 10 pixels down, 10 pixels right is where the top left hand corner of the label will sit. So it will sit just barely offset from the top of the screen. And then we're going to win.blitz, the level label, of course. And here for our XY, it's going to be a little bit different. I want this on the right-hand corner of the screen. So I'm going to take a guess that, actually, you know what? Let's do the mathematical way because we're going through some in-depth explanations here anyways. If I want this to be 10 pixels from the right-hand corner of the screen, what I need to do is determine the top left-hand corner of the label. So where should I put that, right? Let's say, like, I want the label to sit so that the edge of the label is only 10 pixels from the far right-hand side of the screen. So to do that, I need to figure out the top left-hand corner position. Well, what I can do is find the width of this label. I can find the width of the window. And then I can take my padding, whatever I want the padding to be, and use some mathematical equation to figure out where that should be. So thinking off the top of my head here, this is going to be width, which is the width of the window itself. So width minus, in this case, it's going to be level underscore label dot get underscore width. So get underscore width is a method you can use on surfaces that tells you the width of that surface. So since I don't know the width of this level label, because I don't know how big or how long this text is going to be, I need to call that method. And then I'm going to subtract another 10 pixels, because if I left it at this, that would mean that it would be right on the edge. So like the L or like whatever this level number is would be squished right on the edge. So we'll subtract 10 pixels to move it off. And then we'll pick a Y value, which is going to be the same as what we used before as 10, and blit that to the screen. So let's look at this now. And notice we get lives 5, level 1, perfectly in the right position. And say that, you know, we changed the width. So actually, let's do that. Let's change the width to be 800. So let's go like this. If we change the width, everything works fine. And in fact, I can change any numbers I want. Because we've done this in a dynamic fashion, everything will stay consistent. It will stay totally fine. So We'll put them back to 750, 750, but that's why I've been doing things maybe in a more tedious way rather than just hard coding, because I want this to work for any width height that I choose. So let's zoom out a tiny bit there. Let's move that over. And now let's get into some more stuff. So we've displayed the lives, displayed the level. Now we need to make a character. And in fact, we want to be able to move a character around the screen. So the first thing I'm going to do is set up a ship class. So I'm going to say class ship. This is going to be what we call an abstract class, which means we're not actually going to use this class. We're going to inherit from it later. Because keep in mind, we have enemy ships and we have player ships, right? Those are the two parts of our game, really, right? And they're interacting with each other. So the enemy ship probably has some similar properties to the player ship, so we can share that in one kind of upper level class. And you'll understand how this works more, but just follow along with me for now. So we're going to make an init method, and we're going to say, okay, so what are some properties of a ship that we want to store in this game? Well, we need the X position and the Y position of the ship. So where is the ship starting? Is it starting at the top? Is it on the left? Is it in the middle? So let's go X, Y, like that. What color is this ship? That's something that's important, right? So what color? And what about the health? Does this ship have a specific amount of health? In fact, I'll make this an optional parameter of 100, which just says that our default ship has a health of 100, right? So the reason that we need to put color here is because when we have an enemy ship, we don't know what color it's really going to be, right? So that's what we'll define with this color parameter when we create a new ship. Is it red? Is it green? Or is it blue? It can't be yellow because yellow is going to be the main ship, the one that we're using to shoot at the other ship, right? All right, so actually what I'm going to do is remove this color parameter for now, just because since this is a general ship class, for our player ship, we already know what color that's going to be. It's only the enemy ship that will, change its color on initialization. So we'll define that later. But let's just ignore if that confused you at all, the color aspect that I was talking about. So we have self.x equals x and self.y equals y. These are setting up attributes for the class so that each ship we create can store, its X value and its Y value, right? And I'm going to try to go through basics of OOP here, like give you a little bit of an explanation in case some of you aren't familiar with the syntax, but just follow along and understand that what I've done is made a ship. What this class allows me to do is make objects of it, so I can have multiple ships that all have these attributes. So they all have an X, they all have a Y, and they all have a health. That's what the class is letting me do, is later we'll create an instance of it, which means that we can have multiple instances of a ship that all store their own health value, their own X, and their own Y, and they all move on their own kind of terms, right? And that's the idea here. We're going to have multiple things, so let's put it into objects and classes. Okay, so we've done that. We're going to say slash ship underscore image equals none. Talk about this in a second. Slash laser underscore image equals none, and self self.lasers equals blank, and self.cool down counter equals 0. Now, the idea behind this is that when we start shooting lasers, we want to make sure that we can't just spam the lasers. So I'm going to define a cooldown counter here, which essentially means we're going to count and we're going to wait like half a second before we let the user shoot another laser. We'll get into that more later, but we're just starting to class these things out just so that we have that. Okay, so we have that now. Let's define ship. And what we can actually do in here is define a few methods. So the first one that I want to do is draw. So actually, let me go back here for a second just because I feel like some people might be confused on this. So self.shipImage and self.laserImage are what is actually going to allow us to draw the ship and draw the laser. So we need to pick what image from the ones up here that we've loaded in are we going to use for this specific ship. Since this is a general class and it's not going to be instantiated, I'll show you what I mean in a second, we just define them as none for now. But when we actually set up our own ship later and start creating ships, we'll define those images so that we'll be able to use them. Okay, so we have draw. So draw is going to be important for now. And what I actually want to do, because I just want to show you guys how we can move around the ship before we get into anything too complicated, is just draw a rectangle for now. So I'm going to say, we're going to take a window in the parameter. So this is going to tell us where do we draw this, like where are we putting this. And we're going to say window, no, not blit. We're going to say pygame dot rect, sorry, pygame dot draw dot rect. What this says is pygame, use the draw module, dot draw rectangle. We're going to pick where, so we're going to draw that on the window. We're going to pick a color. Let's make this red for now, so 25500 for red. We need to put a rect in here. Now this is a X, Y, width, height, which tells us how big is this rectangle and where is it on the screen. So where is it going to be? Well, it's going to be at self.x, self.y, because that's the position of this ship. And how wide is it going to be? Well, for now, since we're just testing things, let's make it 50 by 50. Now, if we wanted the rectangle to not be filled in, we could define a width. So let's say we define a width of 2. That's going to give us a hollow rectangle with 2 pixel size for the pen size around. But if we want it to be filled in, we can leave it as nothing or put 0 explicitly, which tells us that that means this is a filled in rectangle. Okay, so now that we have that, I'm going to show you how we can use this ship, and then we'll start getting into some more advanced things, but I want to show you moving it around first. So let's make a ship. Let's say ship equals ship, and here we need to pick an X and a Y value to start the ship at. So I want to start it near the bottom of the screen. So what I'm going to do is pick like 300 by 650, and then what we'll do, we don't need to define a health. I want to start it near the bottom of the screen. So what I'm going to do is pick like 300 by 650, and then what we'll do, we don't need to define a health because that's an optional parameter, right? We've already have that defined. Is inside of my redraw window, I want to draw this ship. So what I'm going to do is a ship dot draw window. Now the idea behind this is that this draw method draws the rectangle for us. All it needs is a window. So what we can do is just call that draw method. If there's any more advanced stuff that needs to happen, we don't need to deal with it here. The ship can deal with that itself in its own draw method. So let's just call it with the window. Now we'll see the ship. So let's run this. And we notice that I've made a mistake. Let's see what this makes. Window is not defined. My bad. We need to put capital win in there. Window is the parameter name. I'm messing it up. So let's do win. If we run this, we get this red rectangle popping up at the bottom of the screen. So if I want to start moving this rectangle around now, I need to modify its X and Y position based on what keys I press. So let's do that now. So to do that, we're going to set up a way to track what keys are being pressed by the person. Now, I could show you how to do it inside this event loop, but the issue with that is it only registers one key press at a time. So let's say I press like the side key and the top key at the same time. It won't move both ways. It will only move one of them, whatever one you hit first. I want it so I can move diagonally as well, so I can move at the same time by just holding down keys. So we'll be allowed to do that by pressing both keys at the same time with this method. So what I'm going to do is I'm going to say keys equals pygame.key.get_pressed. What this does is return a dictionary of all of the keys and tells you whether they are pressed or not at the current time. So since this runs once or 60 times every second, I'm going to mess that up every time I say it, so just get used to it. We'll check 60 times every second if we're pressing a key. If we are, we'll move in a certain direction. If we're not, we won't move. So let's say if keys, and in here, pygame.k_. So k underscore is just the prefix for what keys you can use. So you do pygame and then, or keys, since it's a dictionary, we're going to access the value and see if it's true. Pygame.k_, and then whatever key it is that you want. So if you want A, you type lowercase a. If you want to check if the left arrow key is being pressed, you do left. If you want enter, it's actually going to be return. If you want space, it's all capital space. You can see I have this nice autocomplete that's telling me, but ideally you can kind of guess with just lowercase letters, and anything that's like a full word, like enter or something, or return, is going to be all capitals. So if we want to move left, we're going to say if keys pygame.k_a, then we'll go hashtag left. I'm just going to do a comment so that tells me we're moving left. And to move left, I need to subtract from the x value of my player. So I'm going to say ship.x minus equals 1. Now, minus equals 1 means we're going to move 1 pixel to the left. Now, ideally, what I should do actually is define a velocity variable, which tells me how fast I'm allowed to move in every direction. So let's do that. At the top here, I'm going to say player_vel equals, and let's pick some number. I'm going to pick 5. What this means is every time I press this key, I can move 5 pixels. So you'll figure out how fast that is when we start testing the game, but that will also be dependent on your clock speed, right? So if you had a lower clock speed, you probably want a higher velocity because this loop is only running so often. So if I held down my key with a higher clock speed, I'm going to move more because this is going to trigger and happen more times and move me more to the left, right? So let's do minus equals ship_vel or player_vel like that. And now let's do the other keys. So I'll go a little bit faster here. If keys, as I say, I'm going faster, makes a bunch of mistakes. Pygame.k_d. So this is to the right, like that. Make sure I don't forget that colon there. Then we'll say ship.x plus equals player_vel. Then we'll say if keys pygame.k_, and this It's going to be W's for up. We're going to go up like that, and then ship dot y minus equals player.vel, because remember, we're moving up, so we need to subtract the velocity because the starting position is 0, 0 in the top left. And then we're going to say if keys pygame.k underscore s, which is going to be down. Notice I'm using WASD. You could use the arrow keys if you want by changing this to be all capital left, all capital right, all capital up, all capital down. So let's do this. We'll do down, then ship.y plus equals player underscore vel. Okay, so now that we have that, what this will do is move our player. So let's run this and let's have a look. So if I use my WASD, you can see that this cube now moves around the screen. So let's now start restricting how this cube can move, because notice I'm going to go completely off the screen. I can go any direction I want, right? And maybe you might think this is a bit too fast as well. So let's make sure that we can't move off the screen. So to do that, what I'm going to do is say if keys pygame.k_s and ship.y plus player.vel is less than height. So what this is saying is if I add, sorry, not val, what am I saying? Player_val. If I add this player velocity value to the current value of my y, will I be off the screen? If I'm not off the screen, let me move, because I'm less than height, which means I'm not off the screen because I'm trying to move down, right? Otherwise, don't. That's what that's saying. So that's that line. So now let's see the other ones. And ship.y minus minus player underscore val is greater than 0, because we're moving up, so we want to make sure that we're not going to be less than 0 when we're doing that. And for right, we'll say and ship.x plus player val is less than width, right? And we'll say and ship dot, in this case, x minus player underscore val is greater than 0. So now if we run this, you'll notice that I can't go down. Well, I can, but it stops me. I can't go left, right? If I try to go up, I can't go up. If I try to go right, though, I can go all the way off, but just not like only here. Now, the reason why I can go this far off is because the top left-hand corner is what I'm checking. So right now, technically the constraint that I've plugged in here that's in my code is valid because the top left is still in a valid position. What I need to check, though, is if the edge of this cube is hidden. So the way I do that is by getting the width, right? So what I can do as a quick fix here is say if I'm moving to the right, let's add 50 because that's the width of the cube and make sure that the top left-hand corner is further enough to the left such that, you know, even if I'm adding this width, it won't go off. So that's the idea here with going right. And now same thing with the bottom. So if I add 50 to the bottom, so when I'm going down, I want to make sure that the bottom edge doesn't go off the screen. So that's how you do that, is you just add the width to that equation. So now notice I can't go any further than that. And if I go to the right, I can't go any further than that. Now, obviously, we're going to change this because we're going to use like proper graphics in a second. But I wanted to show you how to move first in a more fundamental aspect, so you understand the mechanics behind what I'm doing. Okay, so now that we've done that, let's actually make a proper ship. So let's make a proper player ship that has the proper graphics rather than what I've just done right here. So in draw, what I'm actually going to do here is go window.blit, and I'm going to say ship or self.ship_image. This is just how I reference the attributes that are specific to this ship, so the one that's being drawn. And I'm going to draw this at self.x, self.y, like that. So draw window.blit, self.ship, self.x, self.y. We'll get into the laser stuff later, but that's like further on once we have the graphics working. Okay, so we'll do that, and now what I'm going to do is define a new class. I'm going to call this player. Now the player is going to inherit from ship, which means that it's going to take this initialization and it's going to take it into the, like that. So draw raw. What I'm actually going to do here is go as the and we do, and notice it says you lost, and then the game is going to end and we can run it again. Okay, fantastic. So let me zoom out a bit here so you guys can read some more of the code. I'll kind of at my on my screen. Python, I'm JX ships here. They can move around the screen, and I'm moving these with the same keyboard. So I have WASD moving the one on the left, and I have the arrow keys moving the one on the right. And when I press the left or right control key, that is actually firing bullets. Now there is sound effects. I don't know if you guys can hear them. I'll stop talking and hit it for a second. So you might be able to hear that. Either way, there is sound effects. We'll be adding that in there, and we'll show you how this works. And you can see that